University Calculus. Today we talk about the power rule, a general power rule, which means the power rule combined with chain rule. So let's review what is just a power rule. The power rule says, okay, so if you have a y equals x to the power m, then the derivative y prime is m x m minus 1. Now this is called a power rule. Or you can have a constant multiple, which means if your function is constant times this, and then your derivative is, you keep the constant, and this part is just the power rule. Now, what is general power rule? So the general power rule is you have a function like this. Where v is a function of x. V is a function of x. Then what is the general power rule tells us? Then the y prime is, the first part is just like a power rule. So n times v n minus 1. But then it is followed by the chain rule, which means you do the derivative of the v. So this is a formula for general power rule. Let's have an example. Okay. So our example is y equals square root 1 minus 2x. So how do we do that? Look, this y can be written as 1 minus 2x. Instead of radical, I write exponent. Then this form is a form like this. Y is v to the power n. So this part is v. This part is v. So I call this v to the power 1/2. Then just use this formula. What is the derivative? The derivative is n, so which is 1/2, times v. V is this. This is my v. The n minus 1. What is my n? N is 1/2. So 1/2 minus 1 is negative 1/2. But that's not the end. I have to multiply the derivative of v. The derivative of v. What is v? V is 1 minus 2x. So what is the derivative of 1 minus 2x? The derivative of 1 minus 2x is 0 minus the derivative of this part. But the derivative of 2x is just 2, so it's minus 2. So this is my v prime. So finally, you just rearrange it and rewrite it. So look here, the 2 and the 2 can be cancelled. So what I am left with is just negative sign. I have a negative sign, and I have this part. Look, this part has a negative exponent. So what I have is 1 over 1 minus 2x. I put the negative exponent into the denominator, and the exponent becomes positive. Look, my given function is in terms of radical. So this is already my answer. But since the given function is a radical, I like to change it to radical. So the square root 1 minus 2x. And this is my answer. So I'm using the power rule, general power rule. Okay. Let's have another example. Okay, the next example is y equals a plus b over x squared raised to the exponent 3. So what is the derivative of this? Look, I call this v. So y equals v to the exponent 3. But v is a function of x. So I just use my formula. So y prime is power rule first. 3 goes to the front. And v goes to the exponent 3 minus 1. So that is v to the exponent 2. But my v is a plus bx squared. This is my v, and the exponent is reduced by 1. So 3 minus 1 is 2. That's not all. My general power rule is this. I need to do the derivative of v. Therefore, the derivative of this part, the derivative of a is 0. The derivative of this part, you need to change x squared to x negative 2. So this part is bx to the negative 2. So we do the derivative of this, which is b, negative 2 goes to the front, so negative 2 goes to the front, and x becomes negative 2 minus 1 is negative 3. So this part is my v prime. Now I rewrite it and simplify the result. Let's see now. I have a negative sign here. And 2 times 3 is 6. So I have negative 6. Negative 6. Let's see. I have x to the power negative 3. Therefore, this negative exponent is in the denominator. So I have 2 times 3 is 6 with a negative sign. And I have x to the power 3 in the denominator. I still have a b there, so I should write 6b here. And then I have this. So this is my result. Yeah, this is my result, this derivative. Okay, let's have one more example. The next example is y equals x squared minus x to the power 3. So my next example has the instruction that find the derivative. But you need to find the derivative at x equals 3. You see, the x coordinate is given in this question. I not only need to find the derivative, I need to replace my final x by the value 3. So how do I do that? My solution is y prime. So this is my v now. All right. Power rule. 3 goes to the front. And this v, the power is reduced by 1, so this is 2. Then my v is this. That's v. So this is not the end. The general power rule says I need to multiply the derivative of this part. So the derivative of this part is 2x minus 1. So that's my v prime. That is my v prime. Okay, so I rewrite this. Actually, I don't need to rewrite this, right? So this is my derivative. But now it's not the end because my x should be 3. Therefore, I should write clearly my derivative evaluated at x equals 3 should equal to this. What is 3 squared? 9. 9 minus 3. And I have a square there. Times. What is 2 times 3? 2 times 3, 6. So this is a result of replacing x by 3. So I have 3 times, this is 6. 6 squared, and times 5. So I have 3 times 36 times 5. And then I just calculate this out. The result is 540. So that is my answer. So we have enough examples. We discussed how to do the general power rule, which is just a power rule followed by a chain rule. Let me make a remark that this part, the v prime part, is called a chain rule. Yeah, it's called a chain rule. Okay, this part. This part is actually called a chain rule. So this is my answer. So we are ready to do some we are ready to do some homework. All right. So this is the homework assignment. So we have some problems here. So practice. Practice problems. First one. Okay, what is the instruction? Find the derivative. So the first one is y equals cube root 4 minus 9x. The second one is y equals 1 over the square root a squared minus x squared. So the next question is y equals square root 2x minus 1 over x squared. So the next question is y equals, so y equals, a bracket goes to power 3 over 2, and inside the bracket it is a 2 over 3 minus x 2 over 3. Okay, question number 5. So question number 5, I want to find the y prime at a given x coordinate. Okay, so 5a is the function is y equals cube root x plus square root x at x equals 64. And then 5b is y equals 1 over square root 25 minus x squared at x equals 3. So please practice these questions. It's not difficult. Yeah? We have discussed today's lesson, giving you the formula, and we do some examples. So these are not difficult. So please do that. And that's all for today's lesson. See you next time. Goodbye.